Hello. Today I will guide you through the Hitchhiker's Guide for Upgrading to Oracle Database 19c Live Labs workshop. So I'll be your host the next 50 minutes, and my name is Mike Dietrich. I'm the Distinguished Product Manager for database upgrades, migrations and patching in Oracle. Feel free to follow me on Twitter, and you may also visit the upgrade blog at mikedietrich.de.com. So let's start with the lab. When you receive the link to log on to the lab, you will see the SQL developer on the right side of the lab. This is a standard setup, and we don't need it for the entire lab, so I'll close it here. More important are the instructions, which you'll see in the browser on the left side. When you started this via the green button, you don't need the VNC setup, and you can safely ignore the initialize environment. But we start here in the lab with AWR snapshots. So this will be our first task, and I'll explain this shortly. So in the lab sections, you get objectives and a quick overview, and maybe also some additional information about the features we are using. And below that, you have then the tasks you'll do, with some explanation. So we start actually here by opening a terminal window. Let me adjust that a little bit. And now you see the instructions in the browser window, and I set the environment with .blank UPGR so we can connect to the UPGR database, which is the first database we will take care on and work with. Let me call SQL Plus and then start up the database. Database is now started, and we can start with the first task. We generate an AWR snapshot. So this is put into a script in the scripts directory, and it creates a snapshot. So please note down the snapshot ID 110. We will use that later on. Let us go forward, and we don't have a SSH session here, but we start now a load generator called HammerDB. So you see this on the very left side on the desktop. Double click on the icon and HammerDB opens. Open TPCC, then click twice on load. It will load the load script. Then twice on create. It will create the 3 virtual users, but don't run it now, because there's an additional task. So here in the browser you see all the steps explained. When you do it by yourself, with screenshots you can enlarge them. And before we start the load generator, we will capture from cursor cache. So this script starts now a capture run and pulls the cursor cache for 5 minutes. So don't close that window. It will come back automatically after 5 minutes. So it's capturing, and we can start now HammerDB. And I fast forward here because there's no reason to watch now 3 minutes the load generator. But you see it's about up to 50,000 transactions per minute on the database environment. A little bit more even in some cases. And the idea is that while we did this, we captured the statements, the OLTP statements, directly from the cursor cache. So I exit HammerDB. And then you need to wait a little bit until the script we started comes back. So let's wait. And once it gives you back control, then we can generate another snapshot. Now we have control. And let's generate another snapshot, and this snapshot now gets the number 111. So this was the first task. So we have the load on the database, and we collected already statements directly from the cursor cache, but we have also statements in AWR. And we will take care now on those. So again, some information about AWR. And there's a second script we prepared called capture_awr.sql. And this grabs now the statements from AWR. First I generate a new snapshot, 112. And I have 30 statements from AWR and 38 from the cursor cache, which is not so unusual because often you get more statements in the cursor cache than you have in AWR. Let us do a quick comparison. So 2 SQL tuning sets. STS stands for SQL tuning set, one with 38, the other with 30 statements in it. Now to be on the safe side, we extract the AWR. This generates a data pump export of the AWR, and we have no further need for it here in this lab. But here I can just hit return and confirm the DB ID being listed. In reality, it can be very helpful when you have such an AWR extract and you upload it together with a service request in case an issue is coming up after the upgrade performance is bad. And this helps Oracle support to figure out performance before and after. So now I exported from snapshot 110 to snapshot 112 and I select a directory. So let me quickly check in the instructions which directory. It's the data pump dir. Let me copy paste this in here. And then I use the standard file name displayed 3 lines above. It takes a few seconds and then I have an AWR extract. In case of an SR, case of an issue, I would upload now this data pump export of my AWR. So let me quickly check what had been written. Host command and lslrt on this directory, and you see there's a data pump dump and a log file. So all good. We are done with this section. So let's exit from SQL Plus and go to the next step. So now we collected information from before the upgrade. It's time now to do an upgrade. And we'll do this with AutoUpgrade, which is the only recommended way to upgrade your databases to Oracle Database 19c or 21c or even earlier. So let us connect to the database. I'm already in my UPGR environment and I'm already in the script directory, but I would like to start AutoUpgrade now and let AutoUpgrade generate a sample config file. This file here displayed in this line, I will edit it so it has the right parameters. The sample file gives you an idea how such a config file could look like, but typically it has a lot more information than we actually need. So here you see marked in blue a lot of comment lines and after the parameters comments. So I will clean that out quickly, that we have just the parameters visible which we will need here and use in this upgrade. So let me quickly go forward and then you don't have to watch my limited VI skills. So I have 3 parameters and a global logging directory, and I need one additional one. You can also, when you run the lab by yourself, you can copy paste this entire box into an editor. One parameter is important because the database is in no archive log mode, otherwise I receive an error. It's restoration equals no. This assumes that we don't write a guaranteed restore point. We don't want that. Normally AutoUpgrade would write a guaranteed restore point, but in favor for the lab performance, I don't write extra archive logs to keep it a little bit faster. And this is why we run with restoration no. Now I copy the file over into a new name called UPGR CFG for my config file. Makes it easier to find it afterwards. And when you use AutoUpgrade, the first step is always, once you have the config file, that you run an analyze run. The analyze is non-destructive. That means you can run it as often as you want on your database, and it will examine now your source database for anything which either AutoUpgrade will fix or you have to fix. So let me quickly check with an lsj command, and I'll show you the commands in a minute. We have job 100 on the UPGR database, and it finishes very, very quickly. So the analyze normally is a very quick task. And you see also it writes an HTML status log and a status log file. So status HTML, status log. Let's open Firefox and let us check the HTML file. I prefer the HTML file because it gives a more readable approach to the information or the findings AutoUpgrade had. Open the file. Let me enlarge the browser a little bit. And here you see the pre-check links already. It's job 100 as we saw it before in the tool. So click on the pre-checked report. And there you see an overview on the database, like it's a 11204 database. But more important, we see errors. So this is an error here, and an error would potentially block the upgrade, but there's a fix-up available. And this is important because if there's a fix-up available, AutoUpgrade will fix it. So here again, you see this in the instructions. I would need to run OLS pre-upgrade to move my auditing table into the sys schema, which is a requirement, but AutoUpgrade will do this for me. Same here. Parameter min values, they are too low, AutoUpgrade will fix that. So whenever you find fix-up available, yes, that means AutoUpgrade will fix it for you. It could be also that you see fix-up available no, like here for the hidden parameters, but that simply means that we leave that parameter in the SP file, we don't remove it, and it's good that we don't remove it. It's very important to have that one, because the obsolete threshold should be at 1024 in every database from 12.2 until 21. And here you see more summary for before and after upgrade, like time zone file, swim lengths, things you can check afterwards. But there's nothing to worry about, and most of these items have fix-up available, yes, and the others are not required to be checked. So that's good. And this means we can invoke now the upgrade. So I start AutoUpgrade now, and the difference to the previous call is previously it was mode analyze, now it's mode deploy. I show you a few of the commands AutoUpgrade has. So when you type in help on the job console, it gives you the command overview. The most important one is lsj for list job. But you'll see also that we have commands like to stop a job with abort or resume it, or get more status or restore the job. So we'll use some of these commands, and feel free to experiment with that while the demo is running or while you do the upgrade. It's a lab environment. You are allowed to destroy it, play with it. Please do so. So here lsj, and I give you, let's check a little bit more what the job is doing, the 101. So status minus job 101. And it tells us here that it has moved the OLS table. It has done the prefix ups for the fixed objects, and it's right now generating dictionary statistics, because I haven't done this. If you want a faster upgrade, then you run the dictionary statistics by yourself beforehand. With logs command, you can always find out where the logs are. And I will check the logs now by myself. So I will open a second extern here. And since I used a different log directory, I will use the one here from the output. So go into the file directory. And here you see job 100 and job 101. Let's go into job 101. And you see the pre-upgrade, prefix ups, pre-checks, and drain directories from all the module runs of AutoUpgrade, and we are interested in the DB upgrade because I would like to show you the upgrade logs. One of the huge benefits of the tool, it has no secrets. It logs everything. And these are the 8 workers from the upgrade. Let's tail the 0 worker. So 0 is the main worker, which runs the serial and the parallel phases. And it's halting right now, but here you see it flying. So it's really progressing the upgrade. And you see also the console has switched now to upgrade, so the upgrade is actually running. Now we could monitor and repeat LSJ over and over again, but I show you a quick workaround, which is much nicer than watching a tail -f all the time or retyping LSJ. What we do is in the AutoUpgrade main logging directory. So I climb up a bit, and here under CFG tool logs, there's an upgrade, and below that there's an auto subdirectory. And here there's a state HTML file. And you will see the, how should I say, not the beauty, but it's such a helpful thing. I opened just this stage HTML with Firefox, and it opens a browser window, and this browser window updates itself automatically. So you don't have to do anything. So right now you see that the upgrade is at about 10%, and it will refresh itself. So you don't have to push the reload button, you can just leave that in the background. If I would upgrade now 15 databases at the same time, I would see here a list of all these 15 databases. Now, since the upgrade takes 20 to 25 minutes approximately, we can do something else in between. Of course, we can play around with the job console a bit and see how we can monitor AutoUpgrade, but feel also free to go to the final lab, Transportable Export Import. And the idea of the Transportable Export Import is now that we use another database in this environment, and we migrate it with transportable table spaces while my upgrade is running of the UPGR database, the 11204 database. I migrate now another 11204 database called FTX for full transportable export import. And let me quickly label my X term a bit so we keep an overview on what's happening in which terminal window. So this is called FTX. This is a different database now. And in this environment, I jump to a container database, which is already a 19C. So you see this is 1911. It's a prepared container database. And the idea here is that I create now a fresh PDB, I call it PDB2, in this container database. And once it has been created, I would like to migrate this FTX database from 11204 directly into 19C with full transportable export import. So let me open the PDB. And this is a rule, something I always do, I save the state to make sure that it opens when I restart my CDB, my container database. So let me jump into the PDB, it's now open, all is good. Because I need to prepare a few things before I can migrate my FTX database into it. At first, I create a directory. This is our working directory. And I grant read and write on this directory to the user system, because the user system will be my operating user, which does the cloning or the transportable migration for me. And then I create a database link from this PDB pointing back to the database FTX, which is an 11204 database. So I have now a connection via database link from this pluggable database into the non-CDB 11204 one. So let me connect to this FTX database. So you see it's an 11204 database. And since I would like to use transportable table spaces, but with full transportable export import, I need to set my table space, here it's just one table space for simplicity, to read only. So let me quickly check the table spaces, but you see it's just a playground database. So sysaux, system temp, undo, and the user's table space. So this is the only table space I can migrate here. In reality, of course, it would be way more table spaces. Now, ideally, I copy, and here, don't forget, there's an exit command after checking the table space. Sometimes there are two commands in these boxes, so be aware of that. And I copy the file now to the new location. Then I switch now because I want to transport, and I use that cool feature called full transportable export import, which is transportable table spaces. But when you say transportable always and full equals yes, then data pump takes care on all the manual steps you would have to do with transportable table spaces normally. So I connect now to my CDB2, my 19C container database, where I pre-created my PDB2. So the PDB2 is ready, it's open, it's in good shape, there's the database link, and now I call data pump. And in data pump, I explicitly refer to transportable always and full equals yes. And this way I tell, please migrate over. Everything. File has been moved by myself, and now data pump does all the magic, all the meta information which is related to this database with this table space. So everything, views, synonyms, in system, table space will be moved over. In case anything goes wrong with copy paste, there's also a prepared par file in the home Oracle imp directory. So you don't have to retype the entire command. In the FTX database, I can set the table space now back to read-write. And I can shut it down because we won't need it anymore in this environment, in this demo. Let me connect quickly directly to the PDB. If we want to do that, we need to use the service name. So here I jump directly into the PDB and ignore that the password will expire. So let us do a quick show con ID and show con name. Con ID is 3 and the container name is PDB2. And that's okay, all is set here. That's it. I migrated this database. This could be even cross-platform, cross-engine, as the source could have been on AIX. Then I would have to convert the tablespace files, but that's not rocket science. And let us quickly check. The database upgrade is still running in the background. It's at over 40% now. So here we can exit. The migration is done. Now let's go a step forward and see what else can we do while the upgrade is running. And yeah, maybe we can also do an Unplug-Plug-Upgrade. There's another CDB in this environment, CDB1. And while CDB2 runs in 19C, CDB1 is a 12.201 container database. So let us label this Unplug-Plug-Upgrade. And let's connect to the CDB1 and see it's not a 19C, it's a 12.201. Let me start it up at first. Takes a little second. And here in this CDB, I prepared already a PDB. So if you do show PDBs, you find PDB3, which is a 12.201 PDB. And the idea is now we migrate it over to this CDB2, which is 19C. So we do unplug, then we plug in, and then we upgrade it. So let me do this here. First of all, in this case, we prepared already the AutoUpgrade config file for you, because we'll do this with AutoUpgrade. I don't have the desire to type all this by myself. So source home, target home, then the SID of the source with the specification of what's the PDB's name. And this is the target CDB. So go into CDB2. And very important is also the last line here, target PDB copy option, because I would like to have the PDB copied over and not remain in the source, so I can reuse the original one. I don't want to destroy it. This is my first test. So hey, let's do an AutoUpgrade mode analyze at first. Let us check if it can be migrated or upgraded, unplugged, plugged, moved over. A quick check. Let me do an LSJ, and you have to type very fast if you do this. But I hope that I can catch all the steps. Status minus job 100, and here you see there's a lot of things going on in the background. So it really does the compatibility check. We will do the compatibility check later on manually for another multi-tenant task. But here AutoUpgrade did it completely for me, which is a great relief actually, if I don't have to do that. Let me check the status file here for pre-checks, if there is anything I should be aware. So here I see the overview about the components being there. The container is PDB free here. And we give you a warning, and there's no fix-up available, but it's not just a warning, not an error. If you move it over now and you don't use the copy option, you would need really a good and decent backup recovery procedure, because there's no guaranteed restore point written, which would allow you to go backwards. And please feel free to browse through all the information we give you here. This is still the other one, still running, but I'm going forward with Unplug-Plug-Upgrade. So let me now connect into the CDB2, the 19C CDB, where I migrated already my other database into PDB2, and now I would like to have PDB3 coming over and being upgraded. The analyze went fine. Now let us do a deploy, and the deploy will now unplug, plug and upgrade. So quickly an LSJ here. No, I don't care about the LSJ, I just go in with Firefox, and of course I shouldn't stop the console because this would stop the upgrade, so I simply open a new tab and copy paste here from the instructions my Firefox command, so it opens a second tab here, and you see this is now CDB1. UPGR database here at 60 something %. And here the PDB, we see it in the overview, the details, you see that's PDB3, generating dictionary stats. So we have now two browser windows open, or two browser tabs. I would like to arrange them side by side, because while these two actions are running in the lab, I can't do much. So I arranged them here, and we can see both of them. Now the UPGR database is already at 90%, and I fast forward this because there's no way of watching both upgrades going on. So it quickly advances and does all the necessary tasks, including the post-upgrade steps. Now we are the post-fix-ups, dictionary, time zone change for the UPGR database, additional tasks running in the background, and here it is finished. So UPGR, the 11.204 database, is done. While you see it in the other browser window, the PDB3 is still upgrading. This is okay, let's put that into the background and go back to our instructions. So this is running. I have to go back now to where I left off with the UPGR database with the upgrade. So here we go. We don't need that terminal anymore. Let's clean up a little bit, makes it easier to follow. And back to the instructions. So we generated AWR snapshots. Then we captured and preserved the SQL, and now we upgraded our database to Oracle Database 1911. So upgrade is done. We can exit and then go to the next step. And the next step will be AWR reports. So the idea is now we collected, and the next step is we compare now AWR Diff reports. An AWR Diff reports gives you a comparison for two hopefully comparable workloads. So it makes only sense when you can push some comparable workload to your system after upgrade or migration. So my database is upgraded to 19C. So I set my environment with UPGR 19. You see it's open already. It's a non-CDB database. So let me do another snapshot here. Gets now the snapshot ID 113. And here we see in the instructions, next step is, okay, we start HammerDB again. So let me start it. And I quickly forward here, so we do the same thing as before. We load the driver script by double click. We start the virtual users. And now we can start directly with the load on the system. And I forward here a bit and speed that up. So we see there's some load on the system happening, and a few minutes later, HammerDB should be done. So here we are, and then we can stop the tool again. Before I do this, quickly another snapshot. So I have exactly that period of my load between two snapshots, 113 and 114. And let me now do an AWR DD RPT. This is an AWR Diff report, comparing two snapshot intervals. We can't compare them over a shutdown of the database. So we can only compare now an interval before to an interval after. I specify the number of days. So I know that before upgrade was 110 to 112. And for the second period, I would like to compare to the first period, is now 113 to 114. And I go with the standard report name. So all this is in the instructions as well, of course. And let us quickly now open the report and have a look what's in that report. So here the report is generated, so you see the HTML code in the Xterm written to the file. And now let's have a quick look. Let me enlarge the browser window a bit so we see a bit more, make this bigger. The upgrade of my PDB is still running, so you see it's ongoing. It's now already in the recompilation phase, which is good. Increase the font here a bit so we see a bit more in this report. So first run versus second run. So first interval against second interval. Let me scroll down a bit. The specs of the system, of course, are the same. It's the same environment. I haven't changed anything here. The SGA is a little bit bigger because that had been changed by AutoUpgrade. But what we look first usually is the top timed events or the top wait events. So here you see also CPU time, even though the CPU time seemed to have increased a little bit from before to after. But basically the wait events and their like percentage of the overall DB time and their ordering is pretty much the same. What we watch out here usually is if we have apparently unknown wait events or a complete reorder, which typically points to an issue we haven't had before. But again, it makes only sense if you have comparable workloads and if you have comparable systems. The AWR Diff reports make really not much sense when you have no workload or when your test system is completely underpowered. So you get a lot of information here for the first and second run and the difference, like wait classes, wait events, some of the things we check some SQL statements. So there may be some findings, no guarantee, it just gives you a rough overview on, oh, there may be something you should take care on. So here we see then the SQL, and we can drill down into the SQL statements if we need to. Okay, let's go forward here the PDB recompilation is still running, still happening. Let me move this a bit up. Here we are done with the AWR diffs, and let's go to the next step. So next step then is analyze. What we use now is part of the real application testing pack, the SQL Performance Analyzer, which is my favorite because this gives us such good way to compare performance before after on a SQL level. And it's super simple to use, and you don't have to set up like days. You need your test system, and then it simulates the execution, so this is non-destructive. So I connect to my UPGR database, and first of all, you remember we have these two SQL tuning sets, captured from AWR and captured from Cursor Cache with 30 and 38 statements. And I will use now the SQL Performance Analyzer on these statements, simulate the execution, compare before after, and I will do here in this case metrics and reports on CPU time and elapsed time. We have 6 different metrics we could do reports on if needed. So I scripted everything. When I call sparse CPU here, this does a comparison before after based on CPU time. So it compares the 11.204 information now with the 19C information because it simulates the execution in 19C. So we have everything in the SQL tuning set from 11.204, and now we test execute the same statements again and simulate the execution, and then we compare, and I generate now the reports. So here I trigger the execution for elapsed, and then afterwards I want to see the regressed report especially. So I want to see those statements who are worse than before. And let me open them in Firefox. Don't forget the exit here. This is also a thing, when you do blindly copy paste, it's so tempting, but keep really an eye on what's going on because you may need to hit return here and there. So Firefox is open, and let us quickly compare the two regressed reports. The first one is on CPU time. You may spot it already in the middle of the left side. Here on the last line you see CPU time. And the second report, let me make this bigger as well, is elapsed. So here the report, regressed report for CPU time, and you see some red already. I have a threshold of 2%, so everything below 2% won't be shown. But here I have an overall impact of almost 5% worse. Now, keep in mind, this is a very artificial example. But in reality, you may see sometimes more remarkable numbers. And the idea is we have 3 regress statements. Or 2 actually, not 3. And we find now out a little bit more about these statements. We can check them, the elapsed time before after. You see also the CPU time, buffer gets, costs, reads and writes and so on. So these are the metrics we do the comparison on, also parse time and user I/O. The idea is now we find out, is there a change, something I should be aware of, something I should fix, and how do I fix it? So at first we identify the statements. We know now some candidates, and we'll do the same comparison here in the other report. So this was CPU time. You see these 2. I can't click on the other one. You see always the statement in clear text. Then you see the execution statistics below, and then the plan before after. And let us see if there's a plan change. And here apparently there is a plan change. So while we had a table access per index row ID, we have it now batched, which was added later on, I think. Let us check also the elapsed time. So here we have a few improved statements. The impact is overall good, 7%, but also a little bit of regressions. No plan change in this case here as far as I see. So let me see what we can do. While I'm doing this, in the background, my PDB 3 has been upgraded now, is also 19C. And let us go forward. You can, of course, if you want to, you can play with these procedures. This is why there are instructions. I give you some guidance what you can try out by yourself. like changing optimizer features enable and things like that. But let us fix some of the plans, and the next step will be SQL Plan Management, which is a free Enterprise Edition feature and has also some basic functionality even in Standard Edition. So the idea is now we nail down one of these statements. So we identified a statement which is misbehaving or slower than it was before in 11.2. And what I do here is I use scripts by my colleague Carlos Sierra. So from Carlos Git, you can load these scripts. And I use them, and it displays me now for this SQL hash ID. And this was one of the plans identified before, 2 existing plans. The first one is the plan hash value, a good one. This is the one I want to nail down as far as I remember. Yes. And the second one was not as good. So I check it from the plan baseline, and then it automatically nails down the best plan for this statement. So it's nailed down now. Let us do a quick check if it's really available. And you see it here listed from DBA SQL Plan Baselines. There's the SQL handle, the plan name. So it's enabled and accepted. Both is yes. So this plan is really now engraved in stone. Of course, this only works when you use binds. It doesn't work very well with literals. I can load also all plans. This is something you can use in Standard Edition. I wouldn't recommend that normally, because then you have all plans nailed down, and as soon as your application is not relying completely on binds, you may have one or the other candidate which is not desirable to have in the plan baseline nailed down. But yeah, you can try. Now, I fixed something. Let us do our reports again. So I again do a test execute on CPU time and generate a regressed report. And I again call SQL Performance Analyzer, now for elapsed time, and also generate a regressed report. So both got generated, and let me compare them now again in Firefox, side by side, and see if nailing down the plans had a good impact on performance and if we fixed our regress statements with that. So here's the browser, and the last 2 tabs are the ones I'm interested in. So let me quickly jump into them and again increase the font so we can read here what it says. Scroll down a bit. So the first one is CPU time, the second one is elapsed time. So elapsed time first, you see here elapsed time is the metric. Now overall impact 12%, so wow, this was good. There's not a single statement regressed anymore based on elapsed time comparison. 4 of them are improved, including my candidate. This sounds very good. So we fixed that statement. And it's even much faster than before. And also on CPU time, this looks very, very good. Now 5.6% overall improvement. 2 statements based on CPU time better. My plan I fixed is more or less the same. At least it's below the 2% threshold. And I would highly recommend to work with these thresholds. Otherwise you find almost every statement there. Because it's a simulation, but it simulates 10 times. 1 to warm up the buffer cache and then 9 times again. The other option would be the SQL Tuning Advisor, especially if your application is written badly and uses literals instead of binds, because the SQL Tuning Advisor allows you to fix statements on a statement-by-statement basis, but with cursor sharing force on a statement level only, not for the entire database. Again, I use scripts from Carlos and create a SQL tuning task based on my capture from cursor cache, my 38 statements. And again, we do now a test execution and a simulation. And also the SQL Tuning Advisor tries to optimize them. So this may take a little bit longer. And you see there's a lot of output, and at the end, So you may browse through that output. I won't do this here in the demo, but you will see at the end that there are some recommendations. For instance, here I should gather statistics, and this will generate histograms as far as I'm aware. And another one, and I will do this as well. With the indexes, be very careful. First of all, you will quickly spot that some of the indexes are duplicates. And keep always in mind, creating an index, first of all, on an Exadata may not be beneficial. And second, creating indexes may slow down your DML performance for insert, updates, deletes. So don't blindly create indexes here. Evaluate them. You can also create indexes invisible at first and then verify them. And then if they are really helpful, make them public afterwards or destroy them again. So I created one of the indexes here. The second one, let's do another one. It's a playground environment. The third one, if I do this here, you have to be an eagle eye. This is again a duplication. So this index is 4 times in the recommendations. Don't ask me why. We can't create it another time. And we won't need it another time. But the good thing is with SQL Performance Analyzer now, with the indexes in there and with the histograms, let me verify again. So again, my SPA task for CPU and my regressed report for CPU time. And I do the same thing for elapsed time again. Here we go. And the regressed report also for elapsed time. And then Firefox again, exit, and let me check this in the browser. The last browser tabs. Here we go. Again, increase the font. Both of them. So here we see CPU time. 9% better. Not bad. 3 statements improved. Let me compare to the last run, which was 5% improvement for CPU time. So that added something. Let's do the same check for elapsed time. So here 12.78 improvement. So something like almost 13%, 4 statements. That seems good. Let's compare to before. Also 4 statements, 12.3. I mean, this is something, it's more or less the same, I would say. But the CPU time got even a bit more improved. So it could be beneficial. Now we would have to verify also insert, update, delete performance. Finally, my database is upgraded. I have verified now performance. I'm all set. But I would like to plug it in. It's a non-CDB. And since I have this 19C CDB, the CDB2, and since I can have 3 pluggable, user-created pluggable databases at no extra cost with my license agreement in 19C, I want UPGR to be plugged in now also. So you could do this with AutoUpgrade. But here I will do it manually. If you want to do it with AutoUpgrade, source and target home are the same, and it will be plugged in, and AutoUpgrade does all the magic for you. That's super simple. We go the hard way. We type. You're free to do whatever you want, or both of them. Feel free, but not with the same PDB. Then you need to create another one and modify the file a bit. So first, let me shut down my UPGR database. So UPGR database is a non-CDB and it should become a PDB afterwards. I need to shut it down and start it up in read-only mode again, because if it's not started in read-only mode, I can create an XML manifest file, but the SCNs won't be correct. When I plug in, I will receive errors. So I will start it up read-only, and once it's started up, I can now create this XML file here. And this XML file, feel free when you play with that to look at it, open it in VI or your favorite editor. You will find the file names, but a lot of other information about this database. Then I shut down UPGR because it won't wake up again in the world of non-CDBs. It will wake up as a PDB soon after. Let me connect now to the CDB2, my 19C container database environment. Set server output on, because otherwise we won't see when we do the compatibility check manually. AutoUpgrade would have done this for us and told us, but I do this here and you see the future PDB compatibility is yes. The problem of that procedure is you receive only yes and no. And if it's no, remember, PDB plugin violations, there you can look it up. So what I will do is, I will create now this pluggable database. I give it a new name. It was UPGR before, now it's called PDB1, and I use exactly that XML file I generated. No copy means it stays in place. So it's plugged in. That was super fast. I didn't even have to cut anything in my recording, but it's not a PDB yet. Even though it has a PDB name and it's part of this container database environment, it's not a real one. So let us open it and you'll see immediately why it's not assimilated correctly. It is opening only restricted. And here, one of the most important things with multitenant comes into play. So I do a few format options so we can see and read better what the output of the following query will tell us. And do a quick select on PDB plugin violations. Let me scroll up a bit. You see warnings in the second column, but the important one is those labeled error. Because if you have an error, this will prevent the PDB from opening unrestricted. And here it tells me I need to run non-CDB to PDB. This is like the assimilation script, and resistance is futile, so we need to run that. Otherwise, there's no way back and no way forth. So this has to be run only once in the life of a database. And it will run and turn the dictionary of this non-CDB now upside down to make it a PDB. The part which takes by far the longest is this recompilation in between. So I cut this part out because we don't want to watch it for minutes recompiling. And now the recompilation is already over. It will open the pluggable database and finally open it then unrestricted if everything went well. This looks good. And here we are. It's done. Now it's completely assimilated and there's no way back. Unless you export import. But you can't convert a PDB in a non-CDB. That is not possible. Let me shut it down and start it up again. Again, I always do the save state. Then I connect now to the $CDB root because I want to show you finally that we plugged in 3 PDBs here. PDB2, PDB3 and PDB1 finally, which was the UPGR database before. So all set, everything now in 19C. We can now do some connect exercises, and I showed you already that this last exercise could have been done with AutoUpgrade as well. So that's it from my side. I hope you enjoyed the lab. If you would like to follow us on our YouTube channel, feel free to subscribe. We upload every day, almost every day, new videos. And please feel also free to tune into our blogs, MikeDietrich.de.com, my colleague Rodrigo Schorsch's blog in the middle, and my other colleague Daniel Overby Hansen's blog. Now thanks and goodbye, and we hope you enjoyed the lab. Feel free now to do it by yourself. Thank you.